An offshore platform installation is a complex process that poses numerous hazards. Multiple companies must coordinate their work safely and efficiently to complete an offshore installation. Nippon, a Japanese multinational energy corporation, set out to install a production platform in the Gulf of Mexico. The platform will be set over a previously drilled natural gas well located 90 miles south of the Texas-Louisiana border. After the initial drilling, the well was sealed off and covered. In the offshore oil field, this is known as a mudline suspended well. To manage the complex process of locating, refurbishing, and installing a platform, Nippon contracts Fairwinds International, a full-service oil and gas, engineering, and project management company. Fairwind's first step is to locate a platform capable of being modified to Nippon specifications. The project managers acquire a recently salvaged three-legged platform, also called a tripod, for the project.
Most of these used platforms, they're used for a reason. Most of them have been shut down or shut in sometimes for years, and they typically need a lot of work. Plus, you still have to make them conform to your process. Every well is different and every process is different. So you need to make sure that your facilities are compatible with the well that you're trying to produce.
The platform is comprised of two main components, the deck and the jacket. The deck houses the oil and gas production equipment, while the jacket supports the structure in the 190-foot water depth. Performance Energy Services in Houma, Louisiana, successfully outbids 5 competitors and is awarded the contract to refurbish the salvaged platform. Team Management and Consulting oversees the refurbishment process for Nippon, ensuring that Performance Energy meets all construction specifications. During the refurbishment, performance crews repair or replace valves, piping, and production equipment, install water treatment equipment, fabricate a new helicopter landing pad, and repaint the entire platform. To accommodate the water depth at West Cameron 552B, Performance shortens the jacket by 37 feet and fabricates new mud mats. Additionally, construction crews replace the flooding system that helps the jacket sink, consisting of airtight rubber diaphragms, flood pipes, and flood valves. After the refurbishment is complete, crews prepare to load the deck and jacket onto separate transport barges for a 36-hour tugboat ride to the offshore location. To move the 482-ton deck and the 415-ton jacket, Bayrard Transportation uses heavy support beams called load spreaders and self-propelled modular transporters. The transporters are hydraulic lifters that can be positioned beneath extremely heavy objects that are out of the reach or capacity of cranes. Large steel plates form a path to help balance the weight as the transporters move the jacket and deck. As the transporters slowly move the jacket and deck into position, large pumps reballast the barge to adjust for the shifting weight. The movement and reballasting process requires hours to complete due to the massive weights of the jacket and deck. To ensure the platform components do not shift due to bad weather or high waves, welders connect the deck and jacket to the barges with engineered support braces. The jacket departs first to rendezvous with Tetra Technologies' derrick barge, the Arapahoe. The Arapahoe is a 350-foot by 100-foot floating platform with a main crane capable of lifting 800 tons. The installation process, called a stab-over, requires the crane to lower the jacket over a small well stub called the conductor that protrudes approximately 2 feet from the ocean floor. Before the heavy lifts take place, divers from Epic Divers and Marine sweep a 100-foot radius around the well for debris. To clear the well stub for the stab-over, the divers use a large jetting pump to blast away sand and mud. With the area clear, divers attach the bullet, a steel casing with a cone-shaped tip, over the conductor. During the stab-over, the bullet helps to guide the jacket over the well. After the bullet is secure, weather, the largest factor in offshore installations, becomes a major concern. A platform installation requires almost perfect weather and calm seas for the heavy lifts of the deck and jacket. Unfortunately, winter weather in the Gulf of Mexico is highly volatile. A large storm is approaching, and the project managers must make a decision. The advancing storm leaves too small a window to safely complete the lifts. The only option is to abort the attempt and wait for better weather. When the project resumes, Offshore Specialty Fabricators Incorporated, OSFI, takes over as the platform installation company. OSFI sends their derrick barge, the D.B. William Callip, to set the platform. The William Callip is a larger derrick barge at 370 feet by 137 feet and has a larger main crane with 4 blocks that can support a combined load of 1,600 tons. The Callip crew works in 2 12-hour shifts, 24 hours a day, to complete the installation. As soon as the Callip arrives on site and sets anchors, Triton Diving Services begins the remaining diving operations. The divers first sweep the sea floor around the well. They find no debris and confirm that the bullet is upright and intact. With the area clear, the crew makes an attempt to bring the jacket in along the starboard side of the Callip, just over the well. Steady waves cause the jacket barge to rock excessively, conditions too hazardous to attempt the lift. The crew decides to wait until morning to try again. The next day, the tugboats reposition the jacket barge on the leeward side of the derrick barge to attempt the lift. After the jacket barge is secure, the riggers attach lifting slings to the monstrous 1,600-ton crane nicknamed Godzilla. The crane lifts and tensions the slings to stabilize the jacket, while the braces attaching the jacket to the barge are cut. With the braces cut, the workers return to the Callip, and the crane operator begins to lift the jacket. The crane holds the jacket suspended, while tugboats remove the material barge. The jacket is lowered into the water, where it floats due to air trapped in the legs by the rubber diaphragms. The crew must roll the jacket so riggers can access the sling platform at the top and connect the upending slings to the crane. A diver enters the water and operates a flood valve at the bottom of the leg. This fills the leg with water and rolls the jacket. With the jacket in proper position, riggers attach the crane to the upending sling at the top of the jacket. The upending sling supports the jacket as it turns vertically or upends. To upend the jacket, a diver opens the remaining 2 flood valves. As the legs flood, the jacket bottom sinks while the crane supports it from the top. Once the jacket is upright, the crane swings it around the bow of the derrick barge to the starboard side and positions it for the stab over. A marine survey team from Tesla Offshore uses a remote gyroscope and GPS to precisely position the jacket over the wellhead. The crane operator carefully lowers the jacket to the sea floor as the diver monitors the alignment of the white bullet and bell guide. The diver then relays positioning instructions to the crane operator to finish this critical positioning maneuver. Once the jacket is firmly on the sea floor, the crane operator carefully rotates the jacket to its final orientation, verified by the Nippon representative.
We were fortunate to get the lift on our first attempt. So I have heard horror stories of jackets being suspended, for days before they could actually set it down because the weather got so bad.
The next step in the installation is to secure the jacket to the sea floor so it is able to withstand rough weather and high seas. To hold the jacket in place, the crew drives large diameter pipes called piles through the jacket legs deep into the sea floor. Before inserting the piles, welders attach work platforms around each leg to facilitate the pile welding process. A hydraulic gripper tool allows the crane to lift the piles and insert them into the jacket legs. Stops on the piles hold them in place while the welders connect a second pile. Eagle Oilfield Inspection Services inspects each weld for defects using an ultrasonic detector. Once the inspector confirms the weld, the crane lifts the pile and the stops are cut. The crane then repeatedly raises and lowers the pile to break through the rubber diaphragm and begin penetration into the sea floor. A total of 5 pile sections will extend 210 feet through each leg and an additional 270 feet into the sea floor to keep the platform stable. The welders connect the third pile sections, then a large hydraulic hammer drives the piles into the sea floor. Each foot of depth is marked on the piles, so a crew member can count the number of blows per foot. A high blow count tells the crew the piles have achieved the desired penetration. The Calip crew connects the 4th and 5th pile sections in the same manner until the desired depth is reached. Once the hammer finishes driving the piles, the crew takes a final level measurement. The crane then lifts the jacket legs, and welders secure each leg to keep the jacket level. With the jacket level, welders attach crown shims to the piles around the top of the jacket legs. The crown shims are the main connection that firmly secures the jacket to the piles. The shims help to keep the platform stable by distributing the weight of the deck over both the jacket and the piles. The crown shims are the main connection that firmly secures the jacket to the piles. After the crown shim welding concludes, the piles are cut off 21 feet above sea level. The next step is to install a boat landing for personnel access and prepare for the deck lift. Tugboats ease the deck barge against the port side of the Calip. The Calip crew tries to secure the deck barge, but rough, steady waves make the planned port side lift unsafe. Undeterred, the project managers decide to reposition the Calip and attempt the deck lift from the calmer starboard side of the derrick barge.
Once it didn't work out the way we had it drawn up on paper, we had to make some field decisions and move the barge around. Well, it's not as easy as just saying, well, just drive around to this side, okay? The tugboats had to, rig up to it. They had to pull out. They had to, come in from the right angle, take into account, once again, the wind, the waves. We didn't want to, bump that thing into the side of the barge. So, it probably took 3 to 4 hours to reposition that.
Riggers attach the crane to the large sling atop the deck. The crane lifts and tightens the slings to hold part of the deck weight. This allows welders to cut away the support braces. With the braces removed, the crane supports the full weight of the deck. The crane operator then carefully lifts the deck. Tugboats tow the material barge clear. Then the Calip crew repositions the derrick barge until the deck hovers over the jacket. The crane operator then carefully orients the deck and lowers it on top of the jacket. Though the deck is set, it is not secure. The crane continues to support the deck's weight while welders firmly connect it to the piles. After the welders finish, the inspector confirms the connection integrity using a magnetic particle inspection. With the main welds complete, the crew connects the lower stairs, handrails, and remaining grating to the platform. Once the welding concludes, the workers grind and sand down all welded areas, then add a primer coat for later painting. The platform assembly is complete. Before the Calip departs, the crew cleans the job site and prepares for the final inspection by the Nippon representative. After the inspection, the OSFI and Nippon representatives signed the certificate of completion, concluding the installation of the platform. With the platform assembled, the next step for Nippon is to install a pipeline that connects the new platform to an adjacent platform 2.5 miles away. Team management and consulting oversees the pipeline installation and remaining construction for the project. The pipeline connects to Nippon's adjacent platform at West Cameron 551A. Here, the pipeline ties into a sales pipeline that ultimately brings the produced gas and oil onshore. Global Industries Offshore wins the competitive bid to install the 2.5-mile pipeline. Global Industries Offshore Construction Division performs the pipeline installation using a process called spooling. In the spooling process, workers fully assemble the pipeline on land, then spool it around a large reel for transport. In any offshore project, time is a valuable commodity. The spooling process significantly reduces the time spent offshore during a pipeline installation. The spooling takes place at Global's facility in Carlis, Louisiana. To perform the pipeline spooling and laying operations, Global assigns the Chickasaw, a 275-foot by 80-foot lay barge. The pipe pushers feed the pipeline to the Chickasaw's bending equipment, where tension and hydraulics curve the pipeline into tight, even wraps around a 46-foot diameter reel. During the spooling, welders form a 2.5-mile pipeline by combining 5 half-mile stalks of 8-inch diameter pipe. At the end of the pipeline, the crew installs a connection called the startup joint that anchors the pipeline during unspooling. Before the Chickasaw departs, the crew attaches a metal pipe ladder called a stinger. The stinger prevents the pipeline from kinking or bending as it unspools. Once on site, a survey team verifies the pipeline route, and the Chickasaw begins the laying operations at Platform 551A. The reel unspools as the Chickasaw advances, laying the pipeline out along the sea floor. As the pipeline unspools, workers scan the coating for weak spots using a holiday detector, then cover the weak areas with heated rubber asphalt. The pipeline unspooling stops every 480 feet to install anodes which protect the pipeline from corrosion. The laying continues through the night until the pipeline reaches the end point at Platform 552B. At the end point, welders attach a connection similar to the startup joint called the drop joint. A winch operator then slowly lowers the pipeline end to the sea floor. With the pipeline in position, the Chickasaw demobilizes and 2 other specialized vessels are brought out to complete the job. The first vessel, the Sea Constructor, is a construction barge that performs 2 main underwater or subsea tasks. The first task is to replace an underwater riser pipe on the side of West Cameron 551's jacket. The second task is to use a machine called the mud bug to bury the 8-inch pipeline. Global's mud bug buries the pipeline using a unique combination of hydraulics, pneumatics, and water pressure. United States government regulations require all pipelines in less than 200 feet of water be buried at least 3 feet below the natural sea bottom. The mud bug design allows it to grip directly onto the pipeline, riding down the length of the pipeline until the burial is complete. As the mud bug advances, powerful water jets blast the seabed, breaking up the sand and sediment. Air pressure carries the debris upward, where vacuum pumps suck the mixture through 3 exhaust stacks. The debris is carried away by the current as the pipeline settles into the freshly dug trench. With the pipeline burial complete, the Sea Constructor departs and the Pioneer takes over. The Pioneer crew makes the subsea tie-ins from the pipeline to the platform risers, then test the completed pipeline's integrity. The Pioneer pipe fitters fabricate the tie-in pieces called closing spools based on measurements taken by divers. Next, the divers install the closing spools to complete the pipeline. The next phase of the project is to tie in the pipeline to the sales line at Platform 551A, then complete the well at 552B so production can begin. Back at West Cameron 551A, A construction crew from Shaw Global Offshore Services connects or ties in the underwater pipeline riser to the sales line. The tie-in consists of interconnecting piping and safety valves, which direct the flow of gas and oil to the sales line. The safety valves allow the production flow to be shut off in the event of an emergency or for repairs and maintenance. The construction crew heads in after the final tie-in to the sales line is complete, just as the Spartan 208 offshore drilling rig finishes setting up for the well completion process. During the well completion process, the drilling rig prepares the well and platform for production by installing various piping, safety devices, and equipment. Spartan 208 is a unique drilling rig. It was originally a production rig, but was modified by adding a 146-foot land drilling derrick and modular drilling equipment. During the setup process, better known as tying back, the rig crew brings the suspended well to the surface and installs various safety devices. The main safety device is a blowout preventer, also called the BOP. The BOP contains multiple heavy-duty valves that can stop drilling and seal the well if the pressurized gas and oil begin to escape, a dangerous scenario called a blowout. The completion process begins by inserting drill pipes into the well. The drill pipe serves as a conduit to circulate synthetic oil-based drilling mud that cleans the well. As the mud circulates, it forces debris and trash from the initial drilling upward through a filtration system. The system then pumps the clean mud back down to reach deeper sections of the well. When the mud is free of debris, the crew begins the displacement process that replaces the mud with a cleaner, water-based solution called completion fluid. Both the drilling mud and completion fluid are weighted to help keep the gas and oil from escaping. Once the displacement is complete, fluid technicians cycle the completion fluid through a filter press to completely clean the well. With the well clean, the crew uses logging equipment to confirm the exact location of the production zone, which is approximately 13,000 feet deep. After the logging, technicians use a perforation gun to blow holes through the well casing at the production zone, so the gas and oil mixture can flow to the surface. The crew then inserts a gravel pack assembly that filters out harmful sand and rock particles from the mixture. Next, technicians insert production tubing to direct the flow of the gas and oil mixture to the platform equipment. As the technicians insert each tubing joint, they test each connection for leaks. Once all the tubing is in place, the crew dismantles the BOP and sets up for the installation of the production manifold, also known as the Christmas tree. A series of valves, gauges, and chokes, the production manifold is the main control system for the well. It allows Nippon's production operators to monitor and manage the well's flow. A wellhead technician helps the crew carefully lift the tree into place and ensures it attaches correctly. With the tree secure, a well test crew sets up their equipment for the testing operations. The testers allow the well to flow for a short period, taking measurements with computerized gauges called flow meters. This measurement process is called metering, and it gives Nippon an accurate estimate of how productive the well will be. The testing equipment separates the water and oil from the gas, then deposits the liquids into separate tanks and flares the gas out of two 60-foot flare booms. After the testing concludes, the construction crew returns to make the final connections from the tree to the manifold and from the production line to the subsea pipeline riser. Once the final connections are complete, the Nippon production operators begin the process to bring the platform online. The operator's first job is to run a series of startup tests on the platform equipment. After the tests conclude, the final pieces of production equipment can be installed, the sales meters. There are two sales meters that measure production flow on 552B, a sales check Barton recorder, and a digital pipeline meter. The meters provide a check against each other, constantly measuring data such as flow rate, pressure, temperature, and volume of gas sold. A measurement technician hooks up the meters, then calibrates them to ensure that there are no discrepancies. With the sales meter calibration complete, the operators open the well and the platform begins production.
West Cameron 552 is one of our better producing wells in that field right now, and it couldn't have been as successful as it is without the combined effort of the many contractors that we used on this project.
The West Cameron 552B project demonstrates the technical challenges that must be overcome to drill and produce a well in the Gulf of Mexico. Platform 552B is now operational and is a testament to what safe and effective coordination can accomplish. As coastal oil and gas supplies dwindle, companies must explore, drill, and produce in deeper waters, posing greater challenges. Nippon Oil Exploration is proud to be a provider of energy services and stands ready to meet these future challenges.